So in this case, P, Q, R, and S are points on the circumference of a circle with center M. It is given that the size of angle M1 is 4x plus 40 degrees, and the size of angle S is 5x plus 20 degrees. So ours is to determine the size of angle Q for 5 marks. So the easiest way to get to angle Q is to say the angle at the center is twice the angle at the circumference. But now we realize that we get the size of angle Q in terms of x. Then we realize that PQRS is actually a cyclic quadrilateral. And we know that the opposite angles of a cyclic quad are actually supplementary. So we use that, and to find the numerical value of x, then we substitute it into the size of angle Q to get the numerical value of angle Q. So let's do exactly what we said. So we begin by saying angle M1 is twice as much angle Q, because the angle at the center is twice as much the angle at the circumference. Please finish it for me. Thank you so much. Now we say, well, the size of angle M1 is 4x plus 40 degrees, and this is twice as much angle Q. So dividing both sides by 2, it means the size of angle Q will just be 2x plus 20 degrees. Fine stuff. So we move. We say, okay, if we take angle Q, we add it to angle S, the sum will be 180 degrees, because these are opposite angles of a cyclic quad. But what is the value of Q? Well, it's 2x plus 20 degrees. And what is the value of S? It's 5x plus 20 degrees. And everything is set equal to 180 degrees. So now we collect our like terms. So we say 2x plus 5x, we get 7x. And we say 20 degrees plus 20 degrees, it's 40. And we take this 40 degrees to the right-hand side, so it becomes negative. And you say 180 degrees minus 40 degrees, it's 140 degrees. Then we divide both sides by 7. What is 14 divided by 7? Well, it's 2. So it means the value of x will just be 20 degrees, right? Great stuff. So now that we know the value of x, then we say, okay, we know that the size of angle Q is 2x plus 20 degrees. So 2 times 20 is 40 degrees, plus another 20 degrees, it's just going to be 60 degrees. So this is the size of angle Q, and your happiness here is complete. But let's say you didn't think about it this way. This is how you could have thought of it if you didn't use this thinking. You could have said, yes, I completely agree that the easiest way for me to get to angle Q is to say the angle at the center is twice the angle at the circumference. And then you say, in order for me to get the value of x, I start by finding the size of angle M2. And then I say, Now that I know the size of angle M2 by using the angles around the point, I can now say the angle at the center is twice the angle at the circumference. And then you can use that to find the value of x. And now that you know your value of x, you can go ahead and substitute it into your Q. Do you see that? So you'd be using angles around the point. Angle at center is twice angle at circumference, as well as angle at the center is twice angle at the circumference as well. But I think it's necessary for me to show you, ne? So let's show you that. Yeah, let's show you. So let's begin by finding the size of angle M2. So we can say, okay, if I take M1, I add it to M2, I get 360 degrees. Because these are angles around a point. Or you can say it's a revolution. So we know that we have 4x plus 40 degrees, but we are looking for the size of angle M2, and everything is set equal to 360 degrees. Then you take this whole thing to the right-hand side, it becomes negative. So you get 360 degrees minus 4x minus 40 degrees. So 360 minus 40, it's 320 degrees. And then you say minus 4x. So now that you know the size of angle M2, then you say the angle at the center is twice the angle at the circumference, and give that reason, of course. So you say your M2 is 320 degrees minus 4x, and you say this is twice as much, 5x plus 20 degrees. So you still have your 320 minus 4x, and then you distribute your 2. So this is what you get, sorry. And then you take the x's to the right-hand side and the numbers to the left. So on your right-hand side, you get 14x. And then on your left-hand side, you get 280 degrees. 32 minus 4, it's 28, yes. And then you say 28 divided by 14, you get a 2. So the value of x, once again, will be 20 degrees. So now that you know the value of x, then you can go ahead and say, oh, it means the size of angle M1 will just be 4 into 20 degrees. And then you say plus 40 degrees. So when you say, oh, it's supposed to be, the bracket is supposed to be there. Yes, sorry about that. So when you say 4 times 20, you get 80 degrees plus 40, you get 120 degrees. So this is the numerical value of angle M1. Then you say the angle at the center, M1, is twice the angle at the circumference, which is just angle Q. And then you can say, well, therefore, angle Q is half of M1. So it's just going to be 60 degrees. So you know 2 methods of destroying this cat. You'll just have to decide which one is easier for you to use. Over and out.